Greetings and welcome to my new calculus channel. My name is John Gabriel. So today I'm going to talk about Newton and Leibniz and what they were doing to try and estimate the slope of the tangent line. And both of them basically had an approximation method whereby you take a point like this and you move it closer towards the tangent line, and then as it gets closer to the tangent line, this red line becomes grows to become more and more like the tangent line and has almost the same slope, but never quite, right? So what did Leibniz and Newton miss? Well, I'm going to move this point and I want you to count how many times this red line changes, okay? In other words, how many times it goes on and off. So now, okay, did you count that? Did you count that? Right. So, when they were thinking about this problem, they missed the obvious. And what is the obvious? The obvious is this, my friends, that there is a parallel line right over there to the secant line, and they could have used that to find the slope of the tangent line. And it works perfectly every time, all the time. Okay. So what did the knuckleheads do? They went with limiting the limiting approach where they'd say, oh yes, as h approaches 0, then this secant line, the red secant line slope, gets closer and closer to that of the tangent line. So this is what is very similar to the gorilla effect. In other words, they saw this thing happening in front of their eyes, but they didn't notice that there was a parallel secant line here. That's how the inspiration for the new calculus started, one of the inspirations. So the mainstream community, math community, is incorrigibly stupid. They're ignorant, they're intransigent, and there's no way you can help them out of their delusions. But so if you consider what I just showed you, you'll see that even from the diagram you're looking at ahead, that it doesn't matter how many parallel lines you've got there, okay? So if we had to say, let's get a screenshot of this, like that, and let's paste it into a paintbrush diagram, like this. And you can see now that it doesn't matter really. It doesn't matter. Okay, let's get a tangent line. Let's suppose that is more or less correct, right? So if you, well, I didn't want to do that, but I wanted to do this. Right, now it doesn't matter how you move that secant line, okay? It'll always be parallel to the tangent line. Do you see that? So that means that you don't have an approximating value. It's always the correct value. And so the new calculus was born out of, the derivative was born out of this idea, and then the integral followed very smoothly on this idea. And so in this article that I'm going to recommend to you, you can see why the parallel secant lines all have the same slope. Well, it's something you learned early in high school. I mean, something you should never have missed, right? But you did. So I would recommend that you read this article very carefully and then notice that it fixes your bogus mainstream calculus even with a little effort, because although this term here is never zero unless f is a linear function in your mainstream calculus, in the new calculus it's always zero, and the proof is up here, okay? The proof is right over here. So it says we know that this finite difference quotient is equal to delta because the red secant line is always parallel to the green line. And after cancelling out n plus n, the difference quotient must still be equal to delta, meaning that any remaining expression in Q of xmn must be equal to 0. This is what I named the auxiliary equation. Okay, so you can read about this and find out much, much more and how it's easily definable in terms of the integral. And there's a book that I recommend you buy as soon as possible, because in the not too distant future, you're going to have to teach this if you're a teacher or a professor. And if you're a student, you're going to have to learn it. So this is the book I recommend. What is the New Calculus? Okay. Very cheap book. It's an ebook. And I recommend that you get it, study it carefully, so that you can learn calculus the right way from the beginning, and not the smoke and mirrors that were given to you by the morons of the last 400 or 500 years. If you're not already subscribed to my channel, become one. Tell your friends about this. Tell everybody you know about this. Join me on Discord. Okay, there's a Discord channel here too, where you can become a member if you pass a 10-question test. It's a multiple choice test, and you'd have to do a bit of studying because it's on the new calculus. And the only channels that are available to you initially will be the lobby and the question section. But once you're a member, you'll have access to all of these. Okay, there's lots of interesting things happening here, and we've got a lot of members now. A lot of people, even with PhDs, master's degrees, and whatnot. So I recommend, finally, once again, that you buy this book. It's very cheap, $9.99 in the US. That you click like on my video, that you become a subscriber to my channel, okay, my YouTube channel, and I'll place links to all of these appropriate articles and to this link where you can buy the book on Amazon. Until next time, I'm John Gabriel. Goodbye.